In this short demo, we'll go through some coupled interactions between a high-dimensional image and an hierarchical embedding. For this purpose, we'll use the Indian Pines dataset as introduced in the paper. Here, we're looking at two image and two embedding views. The top row will serve as our detail view and the bottom row as an overview. The top left shows the current region of interest, which now, at the start, encompasses the entire image. On the right, we're looking at the top-level embedding of a 5-level hierarchy. The lower right overview embedding will remain static, while the coupled region of interest embedding in the top right will update upon navigation in the image. We start with zooming into a region of interest, which triggers the embedding to update and jump from the 5th to the 3rd hierarchy level, thereby providing more detail for this image patch. The UI over there starts counting at 0, which is the data level. From here, we can pan into close-by regions. As small pans add new data points into the view, the updated embedding remains coherent. We can always request more or less detail for a region of interest by rolling up or drilling down the landmarks in the current embedding view. Jumping into a different image area that covers a dissimilar attribute space region will essentially randomly reinitialize the embedding view. When zooming out, we see that pixels which stay in view keep a similar color. That is, their representative landmarks remain at similar embedding positions between updates, even though we are changing hierarchy levels. In case we doubt that the embedding we see has converged, we can run more iterations without recomputing the embedding from scratch. Zooming back out to the full image extent will leave us again with a top-level overview embedding.